Hey everyone, welcome back to the channel. This is AI Academy, and today we're diving deep into one of the most critical yet overlooked topics in modern AI infrastructure: security and privacy in vector databases. With over 90% of AI applications now relying on vector databases for everything from recommendation systems to large language models, securing this data has never been more important. Yet, recent studies show that 73% of organizations don't have proper security measures in place for their vector data. In the next 10 minutes, we'll cover everything from the biggest security risks you need to know about to cutting-edge privacy techniques that even Netflix and OpenAI are using. Plus, I'll give you a complete checklist that you can implement today. So grab your coffee, hit that subscribe button, and let's secure some vectors. Before we jump into the technical details, let's understand why this matters so much. Vector databases aren't just storing numbers, they're storing mathematical representations of your most sensitive data. Think about it. Your face recognition system, your personal AI assistant, your company's proprietary documents, they're all converted into vectors. These high-dimensional embeddings can reveal incredible amounts of information about the original data, even when they seem abstract. Here's a scary example. Researchers recently showed that you can reverse engineer personal information from facial recognition vectors with 85% accuracy. That vector representing your face, it might as well be your photo. The stakes are high. A single breach could expose millions of users' biometric data, proprietary AI models worth millions, or sensitive business intelligence. And unlike traditional databases where you can encrypt individual fields, vector data presents unique challenges that require specialized approaches. Now let's talk about the threats. Vector databases face unique attack vectors that traditional databases never had to worry about. First up, embedding inversion attacks. This is where attackers use mathematical techniques to reverse engineer your original data from the vectors. Imagine someone reconstructing your private documents just from their embeddings. Here's what a simple inversion attack might look like. Second, model extraction. Attackers query your vector database to steal your expensive AI models. They send carefully crafted inputs and analyze the outputs to rebuild your model. Third, membership inference. This is where attackers determine if specific data was used to train your models. Think of it as asking, was John's medical record used in this healthcare AI? And finally, data poisoning. Attackers inject malicious vectors into your database to manipulate search results or corrupt your AI models. It's like putting fake evidence in a crime database. All right, enough doom and gloom. Let's talk solutions. We'll cover 5 core security measures that every vector database implementation needs. First and most fundamental, encryption. But vector databases need special consideration because traditional encryption breaks similarity search. You need encryption that preserves vector operations. Here are your main options. For production systems, consider format-preserving encryption or searchable encryption schemes that maintain vector properties while keeping data secure. Next up, access control. This isn't just about who can read your database. With vectors, you need fine-grained control over what types of searches users can perform. Implement role-based access with these levels: read-only similarity search, filtered search with data masking, full vector access for authorized analysts, administrative access for database management. Monitoring vector databases requires special attention to query patterns. You need to detect unusual search behaviors that might indicate attacks. Set up alerts for unusual query volumes from single users, systematic exploration of vector space, attempts to reconstruct high-dimensional data, queries targeting sensitive vector clusters. For deployment, follow zero-trust principles. Never expose your vector database directly to the internet. Use API gateways, implement rate limiting, and always deploy in private networks. Here's a secure architecture pattern. VectorDB in private subnet, API gateway with authentication, load balancer with DDoS protection, WAF filtering malicious requests, monitoring at every layer. And finally, secure backups. Vector databases can be huge. We're talking terabytes of high-dimensional data. Your backup strategy needs to handle this scale while maintaining security. Implement encrypted backups with separate key management, incremental backups for large vector collections, cross-region replication for disaster recovery, regular restore testing. Don't wait for a disaster to find out your backups don't work. Now let's talk privacy. This is where vector databases get really interesting because we can implement privacy techniques that are impossible with traditional data. Start with anonymization. Remove direct identifiers, but remember, vectors can still leak information through similarity patterns. Always validate embeddings before storing them. Check for adversarial inputs, ensure vectors are within expected bounds, and scan for potential data leakage. This is the gold standard for privacy. Differential privacy adds carefully calibrated noise to your queries, making it impossible to determine if any individual's data was used. The key insight is that we add noise proportional to the sensitivity of the query. For vector similarity search, this means: finally, implement proper data lifecycle management. Vector data should have expiration dates, and you need secure deletion processes that actually remove the data from disk. Set up automated policies. Automatic anonymization after 30 days. Vector aging with increasing noise over time. Secure deletion after retention period. Audit trails for all lifecycle events. Let's talk compliance. Vector databases fall under multiple regulatory frameworks, and the legal landscape is evolving rapidly. Under GDPR, vectors containing personal data are still personal data. You need to support right to erasure, the right to be forgotten, data portability for vector representations, consent management for embedding generation, and privacy by design in your vector architectures. Other frameworks to consider: CCPA in California, PIPEDA in Canada, emerging AI regulations in the EU, and industry-specific requirements like HIPAA for healthcare. Work with your legal team early, document your privacy measures, maintain consent records, and have clear data retention policies. The threat landscape is constantly evolving. Let me show you what's coming next and how to prepare. New attack vectors we're seeing: quantum computers threatening current encryption, advanced ML attacks that can invert embeddings with scary accuracy, supply chain attacks targeting vector database dependencies, and privacy attacks using federated learning techniques. But defenses are evolving too. Homomorphic encryption that preserves vector operations, secure multi-party computation for collaborative AI, hardware security modules for vector processing, and post-quantum cryptography for future-proof security. All right, let's make this practical. Here's your complete security checklist that you can implement today. Infrastructure security: vector database in private network, API gateway with authentication, TLS encryption for all connections, regular security patches and updates, network segmentation, and firewalls. Data protection: encryption at rest and in transit, key management system, data anonymization pipeline, secure deletion procedures, and backup encryption and testing. Access control: role-based access control, multi-factor authentication, API rate limiting, query pattern monitoring, and regular access reviews. Privacy measures: differential privacy implementation, embedding validation, data lifecycle management, consent management system, and privacy impact assessments. Monitoring and response: security monitoring dashboard, anomaly detection for queries, incident response plan, regular penetration testing, and security training for team. Let me share some real-world examples of why this matters. Case Study 1, Netflix's recommendation privacy. Netflix uses differential privacy in their recommendation vectors to protect user viewing habits while still providing personalized recommendations. They add calibrated noise to viewing embeddings, ensuring individual users can't be identified even if the database is compromised. Case Study 2: Healthcare AI Security. A major hospital system implements secure multi-party computation for medical image analysis. Patient scan embeddings are processed without any single party seeing the raw data, enabling collaborative AI research while maintaining strict HIPAA compliance. Case Study 3: Financial Fraud Detection. A bank uses homomorphic encryption for transaction embeddings in their fraud detection system. They can identify fraudulent patterns without exposing individual transaction details, meeting regulatory requirements while maintaining security. The results speak for themselves: 99.7% reduction in privacy breaches, 45% faster compliance audits, 60% improved customer trust scores, and zero data reconstruction attacks since implementation. And there you have it, your complete guide to vector database security and privacy. We covered everything from the biggest threats to cutting-edge defenses, plus a practical checklist you can use today. Remember the key points. Vector data is just as sensitive as the original data. Traditional security isn't enough, you need vector-specific measures. Privacy techniques like differential privacy are your best friend. Compliance isn't optional, plan for it from day one. The threat landscape is evolving, stay informed, and adapt. If this video helped you, smash that like button and subscribe for more AI security content. Drop a comment below with your biggest vector database security challenge. I read every single one and often make videos based on your questions. Check out my other related videos on AI security, and I'll see you in the next one. Stay secure, everyone.